All right, let's talk about the wind. We're going to go on a journey today, starting with the massive engine that powers our entire planet's weather and zooming all the way down to those local gusts, the ones that are so famous they have their own names and legends. We're going to see how it all connects.
So here's a question for you. Why is a biting, snow-filled wind in Siberia a totally different beast from a cold, dry gust that's barreling through a valley in France? I mean, it's all just moving air, right? Well, not quite.
To really get it, you can't just look at what's happening locally. The answer starts way, way bigger. To understand the breeze outside your own window, you first have to understand the massive, invisible engines that power weather across the entire globe. And that's exactly where we're going to start.
So here's our roadmap. We'll kick things off with Earth's global wind engine. Then we'll see a seriously powerful example of it in action, the Great Indian Monsoon. After that, we'll look at a pretty stunning new way scientists can actually predict it. Then we'll take a quick tour of some famous local winds with legendary names. And finally, we'll wrap it all up by looking at what it all means for how we actually live with the wind.
Okay, first up, Earth's global wind engine. The best way to think about this is like a giant, natural HVAC system for the entire planet. Heating, ventilation, and air conditioning, but on a global scale. And you know what powers it? It all starts with the sun. See, the equator gets absolutely blasted with direct, intense solar energy. Meanwhile, the poles, they just get these weak, glancing rays. This creates this huge temperature imbalance. And the atmosphere, well, its one and only job is to try and even things out by moving all that heat from the hot spots to the cold spots. That movement, that's wind. The main engine in this whole system is something called the Hadley cell. It's basically a giant circulating loop of air. So right at the equator, hot, moist air gets superheated, becomes light, and rises way up into the atmosphere. It then travels out towards the poles, and as it goes, it cools off, gets heavier, and sinks back down to Earth around 30 degrees latitude. From there, that now cool, dry air flows back along the surface toward the equator, ready to get heated up and start the whole cycle over again.
Now, the Hadley cell isn't working alone. There's a similar heat-driven system called the polar cell, doing its thing up at the poles. But the one stuck in the middle, the Ferrel cell, it's the odd one out. It's not really powered by heat. It acts more like a gear, just kind of caught in the middle, getting turned by the motion of the two really powerful cells on either side of it.
Okay, so that's the big global picture. Now let's see how that abstract model turns into one of the most powerful and absolutely life-altering weather events on our planet. The Great Indian Monsoon. The Indian summer monsoon is so much more than just a rainy season. It's a massive seasonal reversal of wind that affects over 1 billion people. It supplies up to 80% of the entire country's yearly rainfall. I mean, it's literally the lifeblood of the whole agricultural economy. And at its heart, this really complex dance of pressure systems is all about one thing: moving incredible amounts of moisture from the ocean onto land. The main delivery truck for all that moisture is something called the low-level jet. You can just picture it as a massive, fast-moving river in the sky, maybe a mile up, that just sucks moisture out of the Indian Ocean and funnels it directly into the subcontinent. Understanding this jet, well, that's the key to predicting the whole monsoon. And you can imagine being able to predict this event is absolutely critical. For years, scientists have been hunting for some kind of early warning sign. And you know what? They recently found one. But the clue isn't in India at all. It's hundreds of miles away, over a tiny little group of islands, right in the middle of the ocean. 90 days. That's the number. New research shows that a reliable signal shows up almost 3 months before the monsoon even makes landfall. A forecast that early, that is a potential game changer for farming, for water management, and for the lives of millions of people. And this right here is what that signal looks like. This graph is tracking which way moisture is flowing over the Seychelles Islands. For months, you can see the line stays mostly below zero. That means the wind is blowing away from India. But then, look what happens in early March. The whole pattern just flips. It jumps above that zero line and it stays there. That's the switch. That's the exact moment the wind starts carrying moisture towards India, acting like a 90-day heads-up that the monsoon is officially on its way. So, we've seen the global engine and a seriously powerful regional system. Now let's zoom in even further, right down to the local level. We're going to go on a quick world tour of winds that are so famous, so connected to the local culture, that they've earned their very own names. First up, let's go to France for the Mistral. This is a cold, dry wind that gets funneled down from the Alps, shooting right through the Rhone Valley. It's known for being incredibly fast and having this uncanny ability to make the temperature just plummet in an instant. Head over to Eastern Europe and you'll find the Bora. It's kind of similar to the Mistral, another cold wind that just pours down from the mountains. In this case, it's the Dinaric Alps, and it rushes down towards the Adriatic Sea. This wind can be unbelievably powerful, sometimes blasting the coast at over 160 kilometers per hour. Okay, now here's one you've probably heard of, the blizzard. But this isn't just any old snowstorm. A true blizzard is a very specific kind of polar wind. It's violent, it's frigid, and it's filled with so much powdery snow that visibility drops to almost zero. They are a defining feature of winter in places like Siberia, Canada, and the northern US. And just to show you how global these things are, let's head down to South America. Here you have the Pampero. It's this really dramatic line of storms that sweeps across Argentina and Uruguay. It's famous for bringing a sudden, sharp drop in temperature, along with thunder and a complete 180-degree change in wind direction. So let's tie this all together. From trying to predict weather systems that span entire continents to just figuring out how to design a garden wall, this is all about how we as people live with the wind. This quote from that monsoon study really says it all, doesn't it? It means that by reading a tiny little atmospheric signal hundreds of miles away, we can build forecasts that help secure food and water for millions of people. It's such a powerful link between planetary science and human survival. And then you have this. This quote describes how folks in France deal with their local Mistral wind. They just adapt. They grow thick hedges to protect their gardens, and they build their houses to face away from the wind's punishing direction. It's the perfect example of small-scale generational knowledge in action. So, from a tiny atmospheric signal over a remote island to the way a family builds their house in a valley, the wind connects our planet on every single scale. But it leaves us with a really critical question for the future. As our climate continues to change, how will these ancient, powerful patterns that we so deeply rely on, how are they going to shift?